Many people say that the torque of a car determines its acceleration and load capacity. Is this true? What is the torque of a car? What determines the size of the torque? If you are also curious about these questions, you must watch this video today. It explains in detail how the torque of a car is generated and what effects it has on the performance of the car. Before that, we need to understand what torque is. Torque is actually the force that twists an object. For example, if we use a 5-centimeter wrench to tighten a screw, we regard the twisting force at this time as 1. If we use a 10-centimeter wrench to tighten the screw, will it be easier? Is the twisting force amplified? So as long as the wrench is longer, the torque will be greater. Torque also represents rotational force. If the torque is applied to the car, because the wheels are round, to make the car move, the wheels must rotate. The force that makes the wheels rotate can also be regarded as torque. If a car is full of goods and you are asked to push it, but you can't, then you can only call someone to help increase the torque of the wheel, or drop some goods to reduce the load. Therefore, the torque of the car determines the load capacity of the vehicle. The torque on the car refers to the torque from the crankshaft output end of the engine without passing through the gearbox. The torque of the engine is just like screwing a screw. The longer the rocker arm on the crankshaft is, the greater the torque generated by the engine. Therefore, the torque of the car is actually determined by the length of the force arm on the crankshaft. The longer the force arm, the greater the torque. The faster the starting advantage, the faster the acceleration. If two bicycles accelerate from 0 to 40 yards, one with a large wheel and one with a small wheel, if the pedal speed is the same, the bicycle with the large wheel will accelerate to 40 yards in a shorter time. If the two wheels are the same size, the bicycle with a faster pedal speed will accelerate to 40 yards in a shorter time. The same is true for cars. With the same torque, the faster the speed, the faster the start. With the same speed, the greater the torque, the faster the start. It's like a diesel car and a gasoline car. The peak speed of a diesel engine does not exceed 4,000 RPM, while the peak speed of a gasoline engine can reach 7,000 RPM. Although diesel cars have more torque than gasoline cars still accelerate faster. However, if they are both household gasoline cars, it is not wrong to say that the greater the torque, the faster the start. After all, you are not driving a racing car that can run at 20,000 RPM. Anyway, everyone's speed is about the same, so naturally, the greater the torque, the faster the start. Is it very easy to understand?